Hey, this is Mr. James, and in this video we'll be doing an introduction to formal two-column proofs. What we're going to do is take a lot of the algebraic problems we've done before and change them into a two-column format. So nothing is really that new except for the format. So a quick introduction. So far this year, we've made a lot of conjectures. Remember, a conjecture is an educated guess or mathematical theory based on patterns and observations. So whenever we measure something or follow a pattern, we're actually making a conjecture. You made a lot of conjectures in Algebra 1. Do you remember recursive and explicit rules? Making a prediction, a rule, or an equation based on a pattern is a conjecture. So all the number patterns we did, all the shapes and picture patterns we did, we made conjectures for all of those. But there's an issue. The trouble with conjecture is that it's not always right. Your prediction might not always work. That's where proof comes in. Proof is the opposite of conjecture. It uses a logical explanation to show why the conclusion must be true. Conjecture has to do with guessing, an educated guess, but proof is not a guess. It's a fact. To write a proof, you have to explain your ideas by using axioms, postulates, and theorems every step of the way. So it's just like doing regular work, except we have to have explanations or reasons every step of the way. So our reasons are all going to be on this big fat theorem sheet that I gave you. Please have this out on your desk as we're working. A lot of what we do will come from this first section, this properties of equality and congruence. However, occasionally we will use a theorem or definition from the second section using segments and angles with algebra. So let's dive right in. Look at the first problem for me. When you're writing a two-column proof, the first thing you need to have is these two columns right here. The first column is going to be your statements, or your work, and the other column is going to be your reasons. Okay? And so when we're writing a proof, you always start off with what you're given, what you're starting with. And in this case, it's 4 times parentheses x minus 5 equals 12. And at the end of our proof, we should end with x equals 8. So over in our statements, we're going to start by writing down that first given, 4 times x minus 5 equals 12. And our reason for that is that it's just given, right? In the beginning, the first thing you write down is always just given to you. Now from there, let's go ahead, pause the video please, and try and do the work out to solve that equation. Pause the video here. All right, now that you've paused the video, let's go ahead and actually see what the work looks like. You should have hopefully distributed the 4 to get 4x minus 20 equals 12. And then hopefully you added 20 to both sides to get 4x equals 32. And then divided both sides by 4 to get x equals 8. That's where you should end up. That's the easy part. The hard part is the reasons. So what are our reasons going to look like? Well, what's the reason we did this first step? Well, our reason there was we distributed. And if we look at our proof sheet over here, our theorems, yeah, there's distributive property right here. So we're going to go ahead and put distributive property as our first, well, I guess our second reason, okay? And then what did we do after that? Well, we added 20 to both sides. So if we look at our sheet over here, yeah, addition property, that's another one of our reasons we can put down. So then our next reason will be the addition property. And lastly, what did we do? Well, we divided by 4, and I can just guess right now, that's going to be division property. And that ends our proof. It's pretty straightforward. Just the statements is your work, and the reasons is what you're doing each step of the way, why you're allowed to do that. Distributive property, addition property, division property, all on that big fat proof sheet, big fat theorem sheet that we looked at before. Let's hop into something a little more difficult, but not too much. Here we go. This is one of those geometric problems with algebra that we were doing a few weeks ago. Given B is the midpoint of AC, BC equals 2x plus 3, and AB equals 3x minus 1. Let's start this just like we would do a problem a few weeks ago by drawing a figure. Here we've got a figure already partially drawn for us. So if B is the midpoint of AC, that means these two halves are congruent, and I can mark that. well, let's see, BC is 2x plus 3. Got to mark that down. That's what we got to do. Okay. And then AB is 3x minus 1. I'll mark that down as well. And normally we would just skip straight to writing the equation. And what would our equation be here? Well, since B is a midpoint and those two halves are congruent, I would write down that 3x minus 1 equals 2x plus 3. But with a proof, that's not good enough. We have to know why we can write that down. Why are we allowed to write that down? Well, the reason we can write it down is because B is a midpoint. And if we hop over to our proof sheet down to that second section, we look for the word midpoint. Here it is, definition of midpoint. It says if B is the midpoint of A and C, okay, that's what I have, then AB is congruent to BC. Oh, that's what I want to do. That's what I want to do. I want to write down that AB equals BC, and because they equal each other, now I can write that equation. Okay, and then after that equation, what would I do next? Well, I guess I just solve the equation, and then I plug it back in to figure out what AB was. So I think we're ready to write the proof now. Yeah, I think we're ready to write the proof. So let's go back to our two columns and jot some things down here. So remember, how do we start every single proof? We start it with the givens. B is the midpoint of AC, BC equals, and AB equals. That's how we always start all of our proofs. And the reason for that, well, it's just given. Okay, coming straight from over here. All right, next what? Well, I could jump straight to writing down my equation, but I'm not going to. I'm going to write down that step that I wrote down before, right there. I'm going to write down AB equals BC, and then write my equation right after it. And what are the reasons for that? Well, I knew that AB equals BC because B was the midpoint. And so on my proof sheet, I'm going to use the definition of midpoint. And then this next step, well, I'm kind of just substituting in right there. I'm substituting AB in is 3x minus 1, and BC is 2x plus 3, and I'm just substituting right there. So my reason will be the substitution property. From there, all you've got to do is solve the equation. So if you can, try and finish the proof from here. Pause the video and try and finish the proof from here. Well, all you've got to do is solve that equation, okay, by, let's see, subtracting 2x from both sides. And that's going to be, what's that going to be called? It's going to be your subtraction property, because I subtracted 2x from both sides. And then maybe I'll add 1 to both sides. All right, get 4 equals x, and I use the addition property because I'm adding 1 to both sides. All right, now we've got x. But remember, we're not done quite yet with our proof. We still have to plug back in to get what AB equals. And what do we call plugging back in? Well, that's just substitution. So I'll write AB equals 3 times 4 minus 1, substitution. And then the last step is just to simplify and get AB equals 11. That ends this proof. The important thing to remember is that all I've basically done is written my workout just like I would normally do on the left-hand side, and just filled in all of my reasons on the right-hand side. If it helps you, it might be useful to do all of these statements, this work first, and then go back and fill in the reasons second. Let's take a look at the backside. Now this backside is just more of what we've been doing, more proofs. Whenever possible, please, please, please pause the video and try and do the proof for yourself. Then unpause it to see if you're right. If you're stuck, watch the video as much as you need to, then pause it and try and get what you can. Let's take a look at the first one. Given x equals 20 minus x plus 4, prove that x equals 12. All right. Well, again, we always start our proof with the givens. So there that is. And over here, the given. And pause the video here and see if you can finish the proof. All right, hopefully you tried to finish it and you got this work. We're going to combine like terms to get x equals negative x plus 24. We are going to add x to both sides to get 2x equals 24. And then we're going to divide by 2 to get x equals 12. And what are my corresponding reasons going to be? Well, combining like terms, if you notice, there's no combining like terms on our theorem sheet. No combining like terms. And so whenever we combine like terms, we're just going to call that simplifying. And then we added x to both sides, so I used the addition property to get to there. And lastly, I divided by 2, so that's the division property to get to there. That ends this proof. All right, let's take a look at this one. Again, this one has some algebra in it and some geometry, so it might be best to just work out all the regular work, the regular steps first, and then put in the reasons second. Let's try that. So wxy and yxz are supplementary. Okay, so here's my figure. They add up to 180 degrees. Yxz is 10x plus 5, and wxy is 75x plus 5. All right, and that's what I've got to get to at the end of my proof. Okay. Well, remember, I always start my proof out by writing what I'm given. Okay, these 3 givens. All right. And next, I've got to write some sort of equation that links this all together. And I've got to have a reason for it. Well, up here, I've got this word supplementary. And I bet there's something that's supplementary on my theorem sheet. So if I look down here, yeah. Okay, definition supplementary. If 2 angles are supplementary, then adding together, they equal 180 degrees. Oh, that's perfect. That's what I need. So I could say that if I have angle yxz plus angle wxy, they should add up to equal 180 degrees. Fantastic. That's the reason I need. And then I just substitute in these 2 expressions, right in there, a little bit of substitution. Boom. And from here, pause the video if you can and try and finish the problem. Remember to pause. Please pause. All right, here we go. So there's the end of the problem, right? You should combine like terms to get here. You should be subtracting, oh, this should say 180, excuse me. You should be subtracting 10 from both sides to get to here. You should be dividing by 85, excuse me, to get to there, and you get x equals 2. We're not done yet. Obviously, we've got to stop and substitute in to wxy, because that's what I'm trying to prove here, and get wxy equals 155. And how about those reasons? What will those reasons be? Well, let's take a look. If you can, fill them in before I show it. Here they are. Well, at the top, of course, the first 3 statements we have are all from the givens. So I write given there. This came straight from the definition of supplementary on my theorem sheet. Then all I did was I substituted in. I remember combining like terms. Wherever we see that, we're going to write simplify instead. I subtracted 10 from both sides. I divided by 85 on both sides. And then I wasn't done yet. I had to substitute in that 2 into that equation. And then I simplified and got my answer. That's the end of that proof. Again, try and pause here and do the next one before we do it together. In the last problem, we did all the work first and then came back for the reasons. This time, let's try and do it together. Given B is between AC, all right, okay, there it is. AC equals 3x plus 3, the whole thing. All right, AB is negative 1 plus 2x, just that part. And BC equals 11. All right, there it is. So I've got to prove that x equals 7 at the end of my proof. So now, remember at the top, you always write what you're given. There it is, what we started with. And for now, we'll write the reasons too, just given. Now, just like before, I've got to have some sort of reason to write an equation here. Well, up here, it has the word between. So let's look at my note sheet and see if I can find that word between anywhere. Oh, there it is. The segment addition postulate. It says if B is between A and C, then I can add them together to equal the whole thing. And that is exactly what I'll do here. Okay? AB plus BC equals AC, and segment addition property. If you can, pause the video here and finish. And here are the rest of your reasons and the statements. Here's a little bit of work thrown in there to make sure everything makes sense. We've got some subtraction going on here. We've got some more subtraction there. And this last step that said symmetric property, that's just because I ended with 7 equals x, and I really needed x equals 7, and the symmetric property allows me to reverse the two sides of the equal sign. When you're finished, let me know.